Hi, I'm Bianca Coker, and I'm going to share with you today some insights into one of the new math standards, 7.6e. This is one of my favorite because it has to do with probability. The standard says that the student applies mathematical process standards to use probability and statistics to describe or solve problems involving proportional relationships. The student is expected to find the probabilities of a simple event and its complement, and describe the relationship between the two. So I'm going to start off with a little bit of a vocabulary review, a little slowly, because we might not want to do that with our students. Realize that your students in 2014-2015 have already been introduced to probability because of the existing standards. However, with the new standards, probability is moving up. There will be no probability discussions in elementary classrooms anymore, unless the teacher is going above and beyond. So when you encounter these students in 7th grade in a couple of years, they may not have heard of probability at all or very little. So we want to make sure that we use a lot of good vocabulary instruction so that they can get all the terminology that goes along with this really fun mathematical subject. So we'll start off with an event. An event is something that occurs. It's just that simple. For example, rolling doubles when you throw two fair number cubes. Now, a complement of an event, or its complement, is very specific to whatever that event was, because it's everything that didn't happen, or everything else. So if the event is rolling doubles on two fair number cubes, then the complement is not rolling doubles. Does that make sense? So let's look for a minute at how many outcomes there are when two fair number cubes are rolled. To do that, we create the sample space. So the sample space would look something like this. 1 and 1 on each fair number cube, 1 and a 2, 1 and a 3, 1 and a 4, 1 and 5, 1 and 6, or 2 and 1, 2 and 2, 2 and 3, 2 and 4, and so on. Now, if you count up all these possibilities, you'll come up with 36. So that's the total number of outcomes for the event of rolling two fair number cubes together. Now, how many of these outcomes are doubles when the two fair number cubes are rolled? Those I've bolded in our sample space. You'll see them as 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. If you've ever played Monopoly, doubles are a great thing. So if we're looking at the probability of doubles, we're actually looking for the ratio of the number of outcomes that include doubles to the total number of outcomes, total things that could possibly happen. So in this case, we would say the probability of doubles is those 6 doubles outcomes, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, divided by all the 36 possible outcomes when you roll the two fair number cubes. So we see our probability of doubles is 6 to 36, or 6 divided by 36. Notice for a second that terminology that we use, that symbol representation that we use for probability. We generally use a capital P, and then in parentheses, we put whatever that event is. So if you haven't seen this symbol before, that's something that's typically happening in probability. The probability of doubles is 6 divided by 36. And of course, we would always want our students to simplify these fractions to 1/6. Now let's look at how many outcomes are not doubles. By not doubles, we mean we roll those two fair number cubes and it's everything else in the sample space. So we'll cross out our doubles and it's all that's left. So if there were 6 doubles out of 36, how many were not doubles? Well, that answer would be 30, right? So the probability of not doubles is again going to be the ratio of the number of outcomes that does not include doubles to the total number of things that can happen. So we'll write probability of doubles complement equals 30 divided by 36. Notice our little symbol up here. That means not or complement. So we can just write probability of doubles, 6 out of 36. But if we put that little mark here, that means not doubles, and it means our complement. So we would use this kind of symbology to describe our situation. And of course, we would want our students to simplify that ratio as well to 5 out of 6. So we found the probability of an event, we found the probability of its complement, and now we need to look at the relationship between the two. So the question is, what is the relationship between the probability of an event and its complement? In this particular case, it's the probability of doubles plus the probability of not doubles equals 1/6 plus 5/6, which of course equals 1. Now when we're talking about probability in percentages, that's 100%. That means that when we roll two fair number cubes, we're either going to get doubles or not doubles. Does that make sense? So when we look at that relationship, we wonder, and hopefully our students will too, if this relationship holds for all events and their complements. So at this point, we want to jump into some of those process standards related to logical reasoning. And we want to have our students to look at a lot of different situations, a lot of different events. And we want them to calculate that probability and the probability of its complement and check and see if we add those two together, if we get 1 every time. Doing that kind of inductive reasoning with your students and then having them verbalize and write a conjecture about the relationship between an event and its complement will be exactly what the standard calls for. Thanks, and I hope you have a great day.